Okay, so I guess let's get started. So let me start the workshop by asking if you have any questions in particular. Okay, cool. So this is the day 3 for workshop 1, Introduction to Unix Command Line. So this is what we were talking yesterday. So we started with the file permissions. So we saw that there is 3 kinds of people for you, right? So there is you as a user, there is your group, and there is rest of the world. And there is 3 permission level you can give to the file, which are the reading, so you can read the file, writing, you can modify the file, and the X, and then X, if it refers to the file, that means that you do have the permission to execute the file. And if X refers to the directory, you are able to see the content of the directory. Then we saw the few commands like being cat, wc. We saw how the redirection works, right? So if we would like to save the output of the file in output of the command into the file, we can do so, and then we see the difference between overwriting the file and appending to the very end. And we saw the pipeline, so looks, and then I hope you were able to appreciate how the pipeline are powerful. So you are not limited in the number of pipes, and there are a number of steps. And what is nice, you are kind of doing everything into a single line. And grab, and then looking for the particular word, particular string in the file, as well as we were trying to combine the grab and the regular expression. So we saw the seed, which is the stream editor. So we were editing the file, as we say, without touching, right? So we didn't touch the file. So instead, we produced the new version, edited version of the file using the seed. And then if you want to save the version, you can just redirect to a file. Okay, so I think that was all for the day 2. So now we're starting day 3. Okay, so I think the day 3 will be the most intense from the programming perspective, where I will try to introduce a couple of programming conception definitions. So the plan will be try to understand. So, but don't be too disappointed, too stressed if you can't get it. It's still fine. So I will provide you kind of the templates, so which you can use and change things without really deeply understanding. So it's really up to you to which level you want to take it. Maybe you just need a template, which basically can, for example, calculate the sum in any column. And then you copy paste the template, change the column number. That's all you need. Or maybe you want to understand deeply. So again, so take as much information and as you can or as you need. Okay, so let's start with the Oak. So Oak, it's a real programming language. So we're not gonna deeply study it and then all the conception. Instead, we will see a couple of things which are really useful. Again, so that will be kind of provided as a template which you can use. Okay, so what about Oak? So it's another text processor, and usually it works the best with the tab delimited data, or any kind of tabular data in the sense that you do have the columns. There is some, like, yeah, you have a file composed of many columns, like Excel style, I would say, right? And then usually the question you're asking, I want to calculate the sum in the column number 5, or I want to get the maximum value from the column number 7. I want to make a sum from the column number 2 and column number 7 and get the additional column. So those are kind of the questions you currently doing in Excel. But again, if you're dealing with the large file, or you just want to do it on the cluster, you don't want to get the file on the cluster, copy on your laptop, do it in Excel, manually dragging, dropping and stuff. And then, you know, like you want kind of to get the answer again by single, kind of get idea about the file in a single line, just in a second. So this is the right, then if you want to do so, that's the right command for you. So this is how the general syntax will look like. So again, so I think, so Oak, A-W-K, right? Then you have the single quotes right here, curly braces, and then here you put the action to take. So basically here you can say that this is the territory of awk. So whatever you will be writing here, you will kind of be writing in the awk language. So right here, that's the place. And you will say the file you want to parse, right? Okay, so let's start with this very simple example where all we want to do just to print the file. So obviously, awk provide you this possibility, and this is how it works. So I would suggest you compare to that template we just show you, exactly this one, and try to read it by yourself. So you start with the awk, single quotes, curly braces, the file to parse, right? So this is, I'm trying to emphasize that the structure will be always the same. Even though if you go further after the workshop and you try to Google, sometimes the structure may vary. But I strongly encourage you to keep the same structure, just easier for you. Always remember awk, space, single quotes, curly braces, and an action to take. So if you keep this structure, you will be never confused. Okay, so far so good. So what is the action? It's actually, you can understand by reading this, right? So print. So all we do, we're just printing the file. So how awk will work, it just go line by line, and it will print every line. That's all. Okay, so something more sophisticated. So we want to print the column number 1. So to do that, we need to say here $1. So again, the dollar is really popular symbol, which is like all over. So remember, here we are on the territory of awk, right? Right here. So the dollar in awk language means column, right? So we say column 1, $1. Okay. If you're interested more than one column, you can print 2 columns, 3 columns, or as many as you want. So you say, I want to print the column number 1, and then you want to put the delimiter. And then you can choose any delimiter you want. By default, awk use the tab. And so you put the delimiter, which will be \t, which stands for the tab, and the column number 3. So by doing this command, you will get the new file on the screen, which is composed only of the column number 1 and the column number 3. That's it, right? Okay, so any questions so far? Okay, so let's practice. So let's take our HD19 GTF file. You remember the one which is composed only on chromosome 2, 3, and 21, right? And let's print it. Okay, so this is how we'll do it. So if you want to print just the column number 1, you say $1 right here. Column number 4, $4. If you want to print column number 1 and column number 4 together, you just need to put the tab between them, or any other delimiter you prefer. Actually, besides printing, you can do some arithmetic operations. The only thing, just be sure that when you multiply, both columns are numbers, right? Because otherwise it doesn't make sense. I don't think it will give you any error. Instead, it will just give you nonsense results. So just be sure. You can check, actually, you can look at the file and see that the column number 4 and the column number 5, they are both numbers, right? So what we'll get as a result by running this command? So we'll get a file which is composed of 2 columns. The first column is column number 1 from the original file, and the second column is column number 4 from the original file multiplied by column number 5 from the original file, right? So you kind of can change the file on the way, right? So all you want to look, column number 1, column number 2, multiply, subtract, divide, everything. Okay, so any questions before we try? Okay, so let's try one by one. Okay, so let me connect to the terminal. So I hope for the Mac, I hope you're able to connect just using the ls. If you can't see me after the workshop, I will help you. But I really So this is the convenient way to connect. And then more than that, you don't even need to type the whole thing. Just type hoth, press tab. Just because it knows that's the alias, it will be auto-completed for you. So this is also nice. Save you some time. Okay, so we are on the cluster. So we go to the test directory. From the test directory, we want to go to W1 files, where all the working files are. And we should have the HD19 GTF. Okay. So the first command we want to run, this is the just print. So the way I do it, you can follow if you like. So not to have the issue of forgetting closing the single quotes, which will result kind of you in. So actually, let me show what will happen if you do so. Okay. Okay, so you forgot to close a single quote, right? So what will happen, you will kind of get stuck, so the system waits the input from you. So what you do Control-C in that case, and then correct the typo, right? And then it will work. Okay, so one way to avoid this kind of thing, I do have the habit of putting both quotes going back, doing both curl braces going back. Right, so this way you will never forget. If you want to follow, you're welcome to. So print and the file name. Okay. So this way we are printing the whole thing on the screen. So what about just printing column number 1? So you say $1, right? Column number 1. Okay. And that's exactly the column number 1. Right, so you have chromosome 2, 3, and 21. Okay, so what about printing column number 4? So this is the starting position of the genomic feature, like being exon, for example. So again, please reuse your previously entered command. Don't type it from scratch. So this way, kind of, it will be faster. So I'm reusing my previously entered command, and then all I need to change, I want to say column number 1, the tab, and the column number 4, right? Okay, so this is how it will look like. So what about I want to multiply the column number 4 by column number 5? Okay, so probably get some large number. Okay, pretty large. Okay, so on the way you can do many things, right? And then if you like that file or you need it, just save it. So for example, this, I save it to temp.txt, for example. So you want that kind of intermediate output, or like all you need like 2 columns, this result of multiplications, you need it, save it. Okay, so we got that file. Okay, so any questions? Okay, so let's see the very first programming conception, which will be if statement. So the way you can view it by looking here, right? How do you know, can you drink a beer or not? You should take your age, right, and compare. Am I greater than 18? Is your age greater than 18 or 21? If it's true, it's greater, just go and get a beer. If it's less your age than 18, go get a Coke. Right? So this is how it works. Okay, so the same, let's write it down. Using the if, like using the letters. So you say if, and then here in the parentheses, you will have the condition to check. Right? So in your case, you have your age, you know that, right? So you compare. And then the condition is your age greater than 18? And then the answer could be yes or no, true or false. So if it's true, then, so if this condition is true, then make an action, print beer, please, right? Okay, so that's a general idea about if statement. And then we can do many things with it. So say you have a file where you have the names, actually, yeah, the names and some numbers. I think that's how much they are paid per hour and how many hours did they work. Okay, so what you want to do, you want to print those employees who actually worked, and then what does this mean? That the number of hours they were working is greater than 0, right? That means the person was working. Okay, so looks like if statement is involved, so we need to check something. Okay, so this is how we'll write. So before going to this if statement, I again want to point out that the structure looks the same, right? You have the awk, you have single quotes, curly braces, something here, and the file you want to parse, right? So at this point, everything looks good. So let's look at the core right here. So here we say if, right, the condition we want to check. So column number 3, or other words, element, if elements from the column number 3, or better say, if element from column number 3 is greater than 0, those guys, then print. So what awk will do, it will go line by line, and then it will ask a simple question. If the element from the column number 3 is greater than 0, print the whole thing. So if is it true, condition is true, no, it's false. It's not greater than 0. False, false, true, then print, true, print, true, print, true, print. So this is how it will work, right? Okay. And that's the output you will get on your screen. So any questions so far?
Can you choose what to print?
Mm-hmm. Yeah, we'll see it in a second. You can just put $1, $2, and so on. Okay, so before we go to more examples, I want to point out I want to talk about the data types. So the data type discussion can be long. There is in programming, there is many data types and designed for efficiency, right? There is integer numbers, there is real numbers, how many digits you want to store after the comma, and so on. But we will avoid that. Instead, I will just say that there is 2 fundamentally different data types. There is numbers and there is a text. And how they are fundamentally different is that with the numbers you can do many things. You can compare the number. Is it greater than 0? If it's greater than 10, less than 5, and so on. So many things. You can add up numbers, divide them, subtract, and so on. With the text, you can't do much. You have a text, or you can say, this text matching this text? Is this sentence matching this sentence? Or this word matching this word? That's pretty much all you can do. You can't add them up, you can compare them. So, okay, so you can just keep in mind all the time, those things are very different.
Can we specify that within a sentence how many times a word is repeated?
Right, but then underlying thing is still matching. You go through the sentence, you say match, count, match. So the underlying thing is matching. That's a fundamental thing for the text. That's pretty much all. Okay, so let's see an example. So we have some items as a second column, and then I think we have a quantity or something like that. So, and then you can see already that this is the text, right? And this is the numbers. So what we want to do, we want to print information about computers. So given a large file like that, where we know that the item names are on the column number 2, and we want to print the lines where the element from the second column is equal to computers, right? So this is how we'll do it. Okay, again, I will not go into the structure, it's exactly the same, right? You can see it. Let's go directly to the core. This one, right? Okay, so let's read it. So we have the if statement, right? If the condition, If this condition is true, then print, right? So the same, so we are consistent in the structure. Okay, so let's check the condition we are checking. So we say elements from the column number 2, this is it, equal. So when you do if statement, just remember that you do equal sign twice if you want to compare. Is this element equal to this one? So you always use equal sign twice. Yes, exactly. Yeah, no matter what, yeah. Because really in the programming, a single equal sign means assignment. You want to assign the value to a variable. But here we just compare. So if you compare twice, equal sign. And you say if the element from the column number 2 are equal to computers. So the reason you put double quotes, because this is a text. So anytime you compare to a text, you should put double quotes. Okay, so what it will do, it will go again. It will go through the file line by line. For every line, it will check the condition. Is it true that this element is equal to computers? False. You will not print. Is it true that this element is equal to computer? Yes, it is. Print, and so on. Okay, so this is how it will work.
The sign of different would be with the exclamation point.
I'm sorry?
The sign of different, if you want a word different.
Yeah, exactly. You put the exclamation sign and equal. Yeah. This will be not equal.
Only one.
Yeah, only one. And then for equal, you put this. So this is equal. No. Okay. So any other questions? Okay, so this is the text. So just to remind you, that's why we put in the double quotes. Okay, so result, if you do run this command, you will get exactly those 2 lines. Okay, so time for examples. So we have the file which is emt data, and that's exactly the file where, it's exactly this one, where you did have people who were working on it. So what we want to get the amount of money we need to pay for those guys, and then we can achieve that by multiplying number of hours they did work by the rate they are getting, right? Pay rate. Okay, so basically we want to multiply the element from the column number 2 by column number 3, right? So we will have the name of the person and how much we pay, right? Okay, so let's try it. So we do have this file which is called empty. Maybe let's check it first. Let's see what is inside. So that's exactly the file, right? So it looks the same. So name, per rate, and number of hours. Okay, so let's try the command. So it will be awk, and then we write here if. Again, I follow strategy that I, for this parenthesis, I close the parenthesis and kind of go back. So if the element from the column number 3 is greater than 0, then print and the file name. Okay, press enter. Okay, you should see only those guys who did work, meaning that the elements from the column number 3 are greater than 0. Okay, so please use the same command and just change it. So you say print, I want to print the name of the person. I will put the tab and I will multiply the column number 2 by column number 3. Okay. So this way you know how much you need to pay straight away. Okay, so any questions? Does it work? Okay. So let's see what's next. Okay, so more examples. So let's look at the file which is hd19.gtf. So again, gene annotations, and where the column number 4, this is the left coordinate of the genomic feature like exon, and then the column number 5, this is the right coordinate. So we want to print only those lines where column number 4, in other words left coordinate, is greater than 50. Okay, we can do that again using the same kind of structure where we say if the column number, the element from the column number 4 are greater than 50, then print. Okay. Also, using the awk, we can solve the problem of chromosome 2, 21, right? So, meaning that we'll be able to distinguish between chromosome 2 and 21. How? Just saying that we want to see only the lines where exactly on the column number 1 we do have chromosome 2, right? So this is kind of solves the problem immediately, right? So we will not see the chromosome 21. Okay, so also we can find the lines which correspond to the chromosome 2 and modify the output, right? So we'll extract those lines and then we'll just print the column number 1 and column number 3, for example. Okay, so any questions? Here, slightly harder, so you need to put two conditions. I can show you how to do it. So you'll say if this equal to chromosome 2 lowercase or something like this. Yeah, I can show you in a second. Okay, so let's do those first and then we'll see that. Any other questions? Okay, so the first one will be if element from the column number 4 is greater than 50, print. Okay, expect to see many lines. Do you want to know how many? Maybe all of them? Yeah, all of them. Do you want to change the condition? Maybe put more zeros here? No, all of them are far away in the genome. Okay, so I'm just checking if something changes, right? So meaning that there is this number. So given this is the 3000, this is the total number of lines, there is 2700 lines where the left coordinate is greater than this position. Okay, so another command will be if elements from the column number 1 are equal, don't forget the double quotes, just because it's a text, and then double equal sign. So if element from the column number 1 is equal to chromosome 2, then print the whole thing. Okay, looks right. Do you want to count? You can. Okay, looks right. There is 1000 of lines which corresponds to the chromosome 2. Do you want to be more kind of careful in your analysis? Do maybe head just right here, so you will not see you will see just the beginning of the file. This way, and then by tail, you will see only the end of the file. Right, so given the file is very large, so you just maybe want to see the parts of it. This is how you can do tail and head. Okay, so what about we print not only the the whole line, but instead only the column number 1, tab, column number 3. Okay, so this is how we got it. And then again, I put the head just for the reason I don't want to see the whole thing. I just want to see the first 10 lines of my output. Or if you want to see the tail, put the tail. Any questions here? Okay, so we are coming, I guess, to the most sophisticated from the programming point of view, the command, which will calculate the sum of the particular column. So again, so try to understand how it works. If you don't, you're still fine. Just use exactly this line, and then all you need to change the column number. You're good to go. Okay, so let's try to understand how it works. So that's the command. So again, look at the structure, more or less looks fine, right? You have single quotes, single quotes, scroll braces and stuff. Okay, so let's try to read it. So the most difficult here to understand what the variable means. So this is the variable, sum. And then just going ahead, so the variable might have any name. So you give the name. So it could be sum or could be s here, you just give it. So the variable, you can look at the box where you store something, you store the value, right? So in this case, what we'll do, kind of high level, we'll go through the file. At each line, we will put the element from the column number 2 in the box. So going for the file, in the end of the file, in the box, in the variable, we will have all the values, and then all we need to do is just add them up, right? So that's it. Okay, and then the formula, you can write it this way. Plus equal, which will basically means keep adding values to the box. From the which values? The values from the column number 2. Okay, and means go do it to the end of the file. So by doing this, right, by putting the values from the column number 2 into the box, by the end of the file, in the box, which you call sum, but you can call it differently, you will have all the numbers, and then you add them up and print the sum. So this is how it will work. So I have some real-time demonstration, which will be given the box, which we call sum. We go for the file, and then we have a magic button. We go for the file and put the values from the column number 2 into the box. So 4, right here, right? 4, 3.75, and so on. So we put everything. So when we reach the end of the file, right, that's what n stands for. So we can press the button, and then we'll get one number. So we'll add up things. Okay, so we reached, we pressed the button, and then we got the answer. So this is approximately how it will work. Okay, so let's see some examples. So what about we want to calculate the sum of the column number 4 in the file, which is hd19.gtf. So again, so if you understand everything, it's perfect. If you don't, I think that this line looks exactly the same, which I just showed you previously. So the changes are very minor, being the column number right here and the file name, right? Everything else looks the same. Okay, so you can take it as correct. So again, sum plus equal $4, column number 4 to the end of the file, and print the value from the box, or otherwise the value from the variable. That's the file name. Okay. So if you want to calculate the average, you need to know number of lines in that file. To know the number of lines, one way which we are aware of, this is WC minus L, hd19, right? So you can, using the WC minus L, you can get the number of lines, and all you need to do, you need to divide the sum by the number of lines. Okay. And That is fine. But again, I don't like two-line solutions. I would prefer one-line solution. So if you want to achieve one-line solution, you just need to know that NR for the oak stands for the number of lines. So for example, this is an alternative way, which is longer, but still alternative way, how you can get the number of lines from the file. So given NR, which is the number of lines, you can get one line solution for getting the average from the certain column, in this case column number 4, just by dividing instead of the number, which you knew it in advance right here, you just divide by NR. Okay, so if you want to remember that, remember. If not, you're still fine. You have your WC minus L, which will you provide that number. Okay, so you don't necessarily need to calculate the sum or the average for all elements from the column number 4. You can do it for the specific ones. So what about we want to calculate the sum of the element from the column number 4 only for chromosome 2. In other words, only in the case when the element from the column number 1 is equal to chromosome 2. So we just need to put the if statement. So we put the if statement saying that if the element from the column number 1 is equal to chromosome 2, then calculate the sum, only in that case. And then the same thing, print it, then you reach the end of the file. Okay, any questions here before we try it? Okay, so let's try one by one. Sure, yeah, go ahead. Right. It might be a connection problem, but you're saying you're disconnected from the cluster?
No, it doesn't say anything. Whenever I'm doing
Yeah, let me see. Because so this way you will not do something. Oh, yeah, yeah. Okay, so put the place in front of the so what we do, control C. Yeah, so put the place in front. Yeah, yeah. This things like I think there's a couple of types of the single pole, and that was the result. Okay, so let's try those commands one by one. So the first one will be sum plus equal $4 and print sum and the element. Oh, I'm sorry, the file. So if you did everything right, then you should get the sum. Okay, so pretty big number. So what about getting the average? So to get the average, one way we need to know how many lines we do have. And the way to do it, WC minus L, so 3000. So all you need to change here, you need to divide the sum by 3000, right, by the number of lines. This way, you will get the average. That's the average number from the column number 4. So if you want one line solution, you do NR. NR. Okay, and the result is the same. Which starts or which are? Where the you want to say the element from? Right. You do grep. No, the grep. You do oak. So do we have this? Okay, something like this, right? And then you do WC minus L. Let's change it. Let's see. So again, so WC minus L, and then here then you better remove this, but it doesn't matter, but just not too confusing. Okay, that will be your command to calculate the number of lines where the first element is chromosome 2. And then there is 1,000 of those. Yeah, so use the pipeline. Pipeline is really powerful. Okay, so what was the okay, so we calculated the average from the column number 4. What about we want to calculate the sum only for the elements which are chromosome 2, right? Okay. So we just need to put if statement right here. That's all we need. If column number 1, elements from column number 1 are equal to chromosome 2, then print sum. Okay, so number is slightly different.
You did print, if you want to get the average, it print sum divided by NR.
Oh, yeah.
Total lines.
Yeah, right. Yeah, you're right. Yeah, we can't. We should divide by, if we want sum, that's all right. But you're right. If we want to divide, if we want to average, we need to divide. That's a good point. Exactly.
You have the WC minus L to find out how many lines.
Right. So, yeah. Oh, it's still moving. I'm sorry?
Like, could you put that line from before where we calculated the number of lines? Can I put that within another?
No, I don't think so. Yeah, it will get too complicated. You can't do it in a single line in this case.
Can you have the pipeline function within?
No, not. I don't think so. Just because you're getting one number, you want to get one number, which is the number of lines which are chromosome 2, right? So this is one number. Then unless you define a variable and stuff like this, which gets too complicated. You should define the variable where you store that number and use it later on. For that, you can do, I guess, one line. You will need to write the script. So it's like. So sometimes you can do one line, sometimes you can't. That's the thing. Okay, so that's what we let me see. What I'm doing wrong. Okay, not here. Sorry. I mean, you just define them here, like we did, like in the sum. That's a variable. But again, I don't think Oak is a good language you can write that script, so you should use something else. Like the Python, I guess. Yeah, but it's getting quite complicated. You need to write a script of a couple of lines. Okay, so if you want to calculate the sum, the average only for chromosome 2, just be careful that you need to divide not by the whole thing, right, by the total number of lines, instead by the number of lines which corresponds to the chromosome. And to get this number, you kind of need to run WC with the grep, right, and then get it, and then plug in here. Okay. Any other questions here? Mm-hmm. Sure. So this is just to say that you want to reach the end of the file before printing this. Otherwise, you will print intermediate value from the variable on each line. So for example, let's remove it. This should work. Oh, not this one. This one. So if we remove it, see? So you do have whatever number of lines and every, so let me print you the head because it goes too fast. Right, so this is how we start. So at every line, you will print the value from the box, which is the current summation. You don't care about that, that's why you say end. I want to reach the end of the line before printing the value from the box. Exactly. Any other questions?
So you want to stop like halfway through or something?
I don't think, yeah, I don't know. I mean, why would you do that? I would say think better this way. Modify your input, right? So say, for example, head minus this number of lines file, put the pipe and do the awk, right? See what I'm saying? So when we do awk here, we do it for the file, right? But you can do awk as the pipeline, as the second step of the pipeline. So provide the truncated input for the, so something like this. So you do head minus 500 and name of the file. So you got your 500 lines. And now do awk, right? And do your awk calculating the sum. So this way you will calculate the sum from exactly those number of lines, like half, as you mentioned. Does it make sense? Okay, so any other questions? No, the space, no, I don't think so. I mean, just try it. I don't think so. Yeah, try it. Yeah, if it works, you're fine. Yeah, I don't think so. Okay, so any other questions? Okay, so let's go ahead. Okay, so we're done with the awk, actually. That's all I wanted to cover for the awk. So any questions here? In general about the awk. Okay, so again, so it's great if you can understand all the details and nuances. If not, just take this as granted, and that's your template to calculate the sum, the average, and so on. Okay, so let's see how we can sort the files, because sometimes in many cases you need to sort. And again, there's a fundamental difference how you sort the numbers and the text. So if you sort the numbers, those are 1, 2, 3, so on, 9, 10, 11, 12, and so on. If you will sort the numbers as a text, that will be 1, 10, 11, right? Maybe you notice somewhere when you sort your documents. So it's sorted as a text. So, because there is a text comparison, which is different as a number comparison. So for the numbers, what, 10 is greater than 1, or like 10 is greater than 2, but for the text is not. Okay, so just be careful. Sure.
So you mean but like numbers, how do you look at numbers as text?
Yeah, so basically as a text, you look like this, where given, for example, A, and X, so A, well, better say like this. So A is greater than X, just on the position from the alphabet. S10 is greater than 2, because the position in the alphabet is smaller. Right? Okay.
If you print numbers, do they become text or are they still?
No, I mean, when you run the sorting, there is an option to say, how do you want to sort? As the numbers or as the text? So you just need to decide how you want to do it. You just need to, if you, by default, is the text. If you want to sort them as the numbers, you just need to say so by using this -n. And then they will be sorted as the numbers. Okay, so you can sort it as the numbers just providing -n. Also, you can sort by the particular column. So given the file composed of many columns, you can sort by the particular column. Then you need to say the column number and use the -k option. Okay, so let's see some examples. So if you want to sort a text file, this is how we do it. So just sort, and then assuming that the file is one column, right? So we say sort and the file, and then it will sort for us. If we know that the file is composed of numbers, then we just need to say -n, and then it will sort as the numbers. So if the file is composed of many columns, then we need to kind of say by which column we want to sort. So remember that file about sales, right, computers, and so on. So we can sort, that's the file, right? So we can sort by the column number 2, and you can see it as a text. So you just say minus k 2, saying that you want to sort by the column number 2, the file. So if you know that you want to sort by the column number, by the column which are numbers, say n, right? The same thing, minus k3, meaning the column number 3, adding n, it will know that those are numbers. Okay, so any questions? Yeah. Okay, so we will have another thing to cover, and then we'll see some examples. Okay, so the command uniq stands for remove the duplicate lines from a file, right? So, and then it's how the syntax, the general syntax looks like this. You say uniq, some options, and the file. And the options are, you can say, you can count how many times each line occurs, right? So given that some lines are duplicates, you can count how many times does this line occur. Does it occur once, or it occurs many times? To do that, you use minus c. Also, if you want to know only the lines which are duplicates, in other words, occurs more than once, you say minus d, and then that option will tell you that. So let's see some examples. So we have the file which are numbers, just like this. And you want to sort them. So you know, though you want to sort the file as a numbers, that's why you put minus n right here. And then you will sort it. So by sorting, as usually, you will see the output on the screen, right? So if you want to save it, just redirect to a file and give a name to that file. So in this case, we will save the sorted numbers to a file, which we'll call numbers underscore sort.txt. In case you want to remove the duplicates, please use the command uniq, and then the uniq will remove the duplicates for you. The thing is, you can run uniq only for the file which is sorted. So you need to sort the file first, and then run the command uniq to remove the duplicates. So if you don't want to save the sorted file, you don't care about that, right? You can use the pipeline. By writing this pipeline where you say sort the file, pipe uniq. So what will happen, the output from here, which is basically the sorted file, will serve as an input for this command, which will remove the duplicate. So eventually we'll just remove the duplicate without saving the sorted numbers. Okay. Do you want to know only the duplicates? Use the minus d option. Or in case you want to know how many times each element occurs, use minus c. And this is how the output will look like. You will have two numbers. So the second number, the line itself from a file, right, from here, and then how many times it occurs. For example, 7. It tells us that it occurs twice. You want to check it? So 7 right here and 7 right here. So it looks like it's right. Okay, so any questions? Okay, let's try those commands. So the first one, so let's make sure that we do have the file. So the file is numbers.txt. And then what we do sort minus n numbers.txt. So by running this command, we will get the output on the screen. Just like this. And then it will be sorted. If you want to save, please do so. We call the file numbers underscore sort.txt. So that file will contain sorted numbers. So now if you want to get rid of the duplicates, uniq, and don't forget that the file should be sorted. Okay, so one way to know that uniq works, just count. And I guess, right, so if you count, you see 7 here, and then if you count original file, you see 8. Okay, so that's what you expect. You see, you expect the file without duplicates will have less lines than the original file, less or equal. Okay, so if you want to get rid of the duplicates, -d, it's your choice. I'm sorry, not get rid of the duplicates, but just display the lines which are duplicates. In other words, the lines which occur more than once. And -c will tell you for each line how many times it occurs. Okay, so you can see that every line occurs just once, except 7, which occurs twice. So any questions here? Okay, so if no questions, everything works as expected, right? Okay, so let's go to the bash, which is the scripting. So we'll be doing the very first script. And the script is all about automating things. So having the multiple commands, you want to put it in the file and run it. That's kind of the idea behind the scripting. And usually I view the scripting as having the multiple commands in the file which you can run for the different data, right? So, for example, you want to extract the chromosome 2 from the GTF file. You write the script for that, and then your script should work for any GTF file given to you. So as the new GTF file comes to you, you just run the script. So it should be kind of universal to work for any data type you're interested in. It's the kind of idea behind it. Okay, so let's write the very first script, and then this is how we will do it. We will just create a file using the VI, and we will call the file something.sh, because this is the convention. Then you're writing the scripts, you call them the extension you need to use. This is sh, stands for the scripting, as shell scripting. And after we do so, we remember that you don't have the permission for yourself to be able to execute the file. So you should grant the permission for yourself to execute the file, and then we will execute the script. So this will be our very first script, and all it will do, it will print a sentence. That's it. So let's look line by line. There is 2 lines, not much to look. So the very first line, this is the standard line just to tell the UNIX that we want to use the bash scripting, which is the version of the shell script. So other words, take it as granted, always put it there. And the second line is actually printing. So when we print things in bash, we say echo, double quotes, and the text we want to print. You can say hello world. This is what we usually do. Then we are writing the very first program. We say hello world. That's my first script. So when you're done, this is your script. You save it as usually using the VI. And then you're granting the permission for yourself, right? U plus X to execute the script. And then you will see that before the script was white and somewhat this, but then you grant the permission for yourself, it becomes green. So you know you're ready to go. So to execute the script, you say // which stands kind of, you assume that the file is located in your current directory, and the name of the script. And then you expect to see a sentence. Hello world, that's my first script. Okay, so that's the plan. Any questions here before we start? Okay, so what we need to do, we need to do vi and say the name of the script we want to create. So I just call it script sh. Okay, so do you have, okay, my bad. I think I do have that file already. So can you check, I think you do have it as well. So that's a file, keep it there just in case, but let's call our script differently because that file already exists, this one. So this is, you can see it is in green, but then let's call it differently, like script2. So for your reference, you will have that file, which you will create eventually. Okay, so we do vi script2 sh. I mean, maybe very tiny one. I think this. Yeah, quit is normal thing. Kind of quit is that you normally quit the file. Abort, you kind of interrupt some process, or like you interrupt. So basically, quit is normal way to exit the file. Abort is something's going on, the file gets stuck, you want to abort the process. So I guess that's it. Okay, so you do vi script2.sh. So if you already opened like I did, so do this. So again, press enter many times, and then save, quit the file like this, right? Hopefully you didn't open that. Okay, so we do vi script2.sh. The reason for the file name to be different just because we have that file already. So I want to create a separate one. Okay, so we create the file the way we know using the vi, and we say the first line, which is, you can't see it here much, but instead you have just look here what I'm typing, because this will give me different colors. Should be the same for you. Something will be in blue, something will be in different colors. And it doesn't matter if you put the space here or you don't. You can put the empty line, it's all right. And then you say, hello, my first script. Okay, how about that? No, still. Okay, so you should have exactly those two lines inside your script. So if you do, just save. Make sure you close the double quotes and so on. So actually that's one way how you can check that you did everything properly, that the colors should match. So the very first line, this one should be in blue, echo, because this is the command, should be in orange, and the text between the double quotes should be in red. So by looking at your script by colors, you can see that you did good job. If you forget to close, everything will be red or everything will be blue, so something wrong, right? So that's a way kind of to find the bugs, to find the typos in your script. Okay, so save, press escape, shift semicolon, WQ, do ls, let's see, the script is here, and then it's white. The reason it's white because we don't have the permission to execute. Let's grant the permission to execute the file. So we do chmod u as a user plus x execute and the name script2. Okay, so now we are ready to run it. Okay, and then what do you expect? Oh, I'm sorry, that's my bad. Yeah, we should script2 all the time. I'm sorry. So we are doing, maybe we should remove that. How about removing that script? And then let me show you, that's a good opportunity to show you. Actually, no, sorry, I'm sorry. Yeah, I think we're fine like this. So let's remove it. You should get this, because otherwise we are too confused. So, and then you should get the warning. Say yes, and then I hope no confusion, no more confusion. Okay. Let's run script2.sh. Okay, what do you expect? You expect to see a sentence which was between the right here, like in there, right? Does it work?
So the first line is just telling you to find the program. Where is the program?
Yeah, it's just telling you that you want to write in the language which is bash. That's all it does.
Yeah.
So it, okay.
Yeah, but you're writing bash. So if you don't put anything, it's going to work anyway.
Yeah, it will, just because by default on the Hoffman, the bash, so the bash is the default on the Hoffman.
Yeah.
But I think it's better to write it, just be safe, as well as if you switch to the cluster, another one, bash could not be default, so we'll get there. Right? But again, if you're only planning to work on the Hoffman entire time, you'll fine not putting this time. Okay. Any other questions? Okay, so that was the first script. So let's do something more meaningful, right, rather than printing the sentence. And this is exactly what we want to do. So we want to create such a bash script which will split the GTF file, which is the hd19.gtf, into the files which corresponds to the chromosome 2, 3, and 21, save every file in the separate directory, which we'll call chromosome 1, chromosome 2 underscore GTF, chromosome 3 underscore GTF, and chromosome 21 underscore GTF. Okay? So if I ask you to do so, I'm sure you will be able to. Just running maybe 5 or 10 commands, and you will achieve that. So instead, I want to put all those commands inside the script, right? Okay. So this is the script. So let's look at it. Is there anything we don't know? I guess the first line we already know, just printing, it's not meaningful, you can remove it or keep it, doesn't matter. Then there is 3 lines which will create individual directories, right? mkdir, this. Then there is grep. So I guess the only thing you don't know, this is the $1. And dollar again is very popular, means something else for the bash. So what does it mean? We'll get in a second. I want to finish with the script and then explain you what $1 means. So let's look at the grep. So that's exactly the command we used before, right? So we try to distinguish between chromosome 2 and 21. That's why we put the space right here. And then we save it into the individual file, which does not exist, but will be created for us. Right, so everything looks familiar, right? And this line exactly the same, and so on. Okay, so let's see what the $1 means. The $1 means the command line argument. So what is that? So that will be the file, the GTF file you want to, from where you want to extract the chromosome 2. So of course you can tell me that why don't you put the file name exactly here? Right, all you need to do is just put hd19.gtf and then that will work. The problem is then the script becomes usable only for that particular file. You got a new file, you need to go inside the script, change the name. I don't like it, and then I think nobody will like it, just because every time you got new data, you need to change the script. The idea behind the script, as I said, is to make it kind of universal to work to any new file which comes to you. So that's why we need this $1, which is the command line argument. This is the way you can tell the script for which file to run. So in this case, when we run the script just like this, we will specify the file we want the analysis to be run, right? We got a new file, just say a name. Just here, just put a new name here, and then it will work for a new file. So this, it becomes kind of general universal. So the command line argument, that's the way to communicate, right? So when you run, how can you tell the script for which file to run? That's exactly the way. So you run your script, you say that you want to run the script, ./script.sh. Then you put a space and you provide the first command line argument. So the first, and then you provided it. So as you run, and then the convention is that if you say $1 in the bash, that will mean the first command line argument. If you say $2, that will mean second command line argument. How you put the second line argument, space, and the second line argument. Okay, so this is how it works. So this is just the way to tell the script some extra information that it wants to use. Okay, so the plan is to create the script, to run it, and see if it works. Meaning that all the directories were created, and then inside the directory you have an individual GTF file which only corresponds to the chromosome 2, 3, and 21. Okay, any questions here? Okay, I suggest to use the same file, the same script file. I don't think you need to create a new one. You can keep the sentence, you can remove it, it's up to you. It does nothing except printing, so it's alright to keep it. And then I write those commands that I would normally run from the command line, but now I'm putting them into the script. Okay, so we will create individual directories. Then the next step will be grab chromosome 2 space \s. And again, you see the special case characters by ping. I do see that ping. And that's the reason is just because you want the VI makes the script readable, right? So it will be kind of easier for you. So $1, different color again. And then you want to redirect to your directory which you just created, which is chromosome 2 _ GTF, and the file name chromosome 2.gtf. So at this point, I will just copy this line and change it. But be careful that you change everything. So here, everywhere should be chromosome 3. Chromosome 3 here, here, and here. 3 times, 3 places. If you do copy paste, just be careful. And the same 21, 21, 21 here, and 21 right here. Okay, so looks good to me. So if you're done, just save the script. WQ. And let's run it. So you need to provide, so this is how we did before. So now don't forget to provide the command line argument, which is the file you want to parse and extract things.
So after like caret, so that comes into that's like telling you to put it in that directory and then it makes that new file.
Exactly. Yep. Okay, so I think some directories already exist because I ran it before, so I should save the beta version online developer, but it's alright. So please go to those directories which you created. So let's go to directory 21. And then you would expect in that directory to have the file. But about that file, you expect that file to contain only chromosome 21. So why we can count WC minus L, chromosome 21, 1000 of lines, looks right. We can do also head, looks right, 21 only, and the tail. It kind of gives the idea that the file is correct and then only chromosome 21 is there. Okay, so let me leave it here so you will be able to follow, and then I will make sure that everybody got the expectable results. How about that? Okay, so you run it? You run the script?
Yeah. So that the file is here.
Yeah, just go to any directory. Oh yeah, you went there. Okay, do ls.
That's it.
No.
The last. Yes.
No, ls. No, just do ls. Just see if the file is there.
Just the last.
Okay. Okay, the file is there. Just do it. So now check number of lines. WC. No, but you want to say which file. But into the control, you can see that stuff. Okay, it's expect open to head, tail, and to make sure that things are.
I'm actually not that right now. Oh, like.
Yeah, sure.
So it like it printed the part and then watched that. How do you make it so it's not stuck for it doesn't? I mean, like, can you put it into the script so that it will just like do that?
No, it shouldn't be. I mean, it shouldn't be stuck. Okay. You can use this. You need to provide the file. You should say invitation. Okay, so because you run previously, the directory is already existed. So just go to any directory. As well as make sure the file is there. Yeah, and then we can check number of lines, first lines, last line to make sure that everything.
I got this, can I create directory?
Yeah, I think it's like because they already exist, I forgot to remove them.
Oh, okay.
Okay, just go to any directory.
Oh yeah, they're right here.
Okay. So just go to any directory and then check if you go to chromosome 21, see if the file is there, how many lines does it have.
Okay, okay.
Everything looks as expected.
Okay.
That's it. Okay, great.
But then there's nothing there. It's so
Sure.
and it does this, and there's
So
there's nothing.
okay, sure. You're right. I mean, but yeah. So the file is there, but it's empty.
There's
Okay.
and I checked multiple.
Sure.
There.
Okay, cool. So go.
So maybe
Yeah, let's check this.
into directory.
No, but we should go back one level up. Okay. So you created this. You also come with 2 underscore 2 underscore. So then you start from no, it's not right. Can you show me how you run it? Save it. See how let's see how you run it. Use the up key and let's see the previous.
Yeah, it's probably fine. Because I tried to find it.
But did you provide the phone number and address?
Maybe this.
backslash. What will be slash? It should be backslash.
Oh.
Yeah. Try it.
Base.
No. Now you. Yes. No, it's not the best. It's interesting. You will not say correct. Okay, so it's all right. So I mean, that's not considered good for this. You can do it. It's not the best way. But then you will get this. Yeah, I mean that's the shift, column, W2, or if you don't want to say exclamation sign. Okay. So now, because you can call it properly, you need to put exclamation sign over there. So it will be shift, semicolon, W2, and then exclamation sign. Okay. Yeah, it's all right. I think it's like, I forgot to, yeah, I forgot to remove those. So it's kind of, but it, yeah, but it's fine. Okay, that's the problem. Yeah, let's see.
Well, you said this is general syntax, so if the system, so in the clusters here in the Hoffman, they always use bash, so it's not real necessary. When you're using like a different cluster somewhere else, that kind of just tells it you're using the bash scripting. I have no idea.
Yeah, but then if you close the session, it will come. So now, everything is fine. Alright. So now you just need to go to this directory and see that the voice is in one for the So the file is there. You can count the number of lines, the tab, but make sure that everything is good. Right. No, I usually don't. Usually you can call separately from the data. Yeah, but it is not
But I know that I made an error in my script. So this has the file name of these two dollars. So how do I go back and edit this?
Yeah, I mean, the idea is to create a new one for the data because
Okay, because I thought I did it in 19.
Alright.
Oh.
And then just go to the directory, do a lens, the file is there, count number of lines, see the heads, and everything. Right. Command line admin works. So command line admin, whatever you do, then you run. Yeah, if you want to do $2, that will mean the second. Space, and you provide a command line admin. And so, exactly. No, you did, but the directives were there. Okay, so the thing is that if they are there, it says it's possible that you can't create them, so they already exist. That's a yeah, I think the files, the directory where with the directives. But we can just go to the directories that say one of the first one and see the input file. And this is what we can run the stories. People are okay. So go over. So you see the count number one. Double the okay.
Okay, does it work for everybody, the script, right? You're getting expectable results. So this is how we usually do. I mean, we're humans, so we make typos, we make bugs, and so on. So usually you just want to make sure that the things are right. You go to some directory, you see how many lines you have in the file. Does it look expectable? It does. Then you look at the tail of the file, and so on, right? So you do those things to make sure that things are run as expectable. And another thing, you don't want to see the errors. So again, so that's kind of my bad. I forgot to remove the directories. That's why we're seeing this error that the directory already exists. But usually you should not see any errors, which is kind of a good sign. But it not necessarily mean that everything works as expected, just not having the errors. That's kind of the first step. Second step, you want to check kind of, take a couple of instances and check manually if the thing works as expected. Because there is two things. The script might work, but might do different things that you would expect it does, right? So, okay, so.
Is there something that we could add to it to, like, if we want to run it again later and want to just replace it to, like, force it to replace the things?
I think by default it will. It says that directory exists, so it cannot create the same directory, but it will go to the directory and place a new file. That's why you have override here, right? So there is two things. It can't here create the same directory because directory exists. It can't. But here it will override whatever is in that directory. So as soon as you run something for the new whatever GTF file, you will override the content here.
So if it can't do something, it'll still run the rest of the script?
Yes, yeah, that's the plan. Unless it fails, like unless there is a syntax error. For example, you do the typo, and then as a result, the command doesn't look as expected. I mean, there is a syntax error, so it will crash. And then, yeah, but then if syntax looks right, it will go to the end.
Like if you forgot the...
Yeah, if you got the double quote or anything like this, it will crash. It will not work. It will go to that end. It will run until it hits this syntax error, and then it will crash. Any other questions?
What if you do a script that actually messes up with your files? Is there a way that you can do a preview of what you do?
No, not really. I mean, scripts are, how should I say, there is, I think, the scripts are kind of basic level where you can debug them in a sense, like you can predict what they do. So usually as you're doing the programming, you have a way to check if there is no syntax error in advance. There is a debugging step which tells you this is error, this is the line there, and so on. In the scripting, you don't have this. Unless you run it, you don't know. That's kind of the disadvantage of the script. For example, for the Python, you would have the possibility to know where the errors are and so on. So you kind of need something more advanced, I guess. Yeah, but then other than that, yeah, just be careful. Yeah, I don't, because even though it might look nice from the scripting perspective, right? But then you might still lose some important files. If you, So that's the thing. I mean, usually keep scripts in one directory, files in another one, and never run, or like you can do override here if you want, but then, or like run for the different directory, for the empty one. So every time maybe change here, or like for example, you run it here, so the content you save somewhere else, and then run the second time, so you're fine, something like this. So those kind of things. Any other questions? Okay, so I guess we will be talking now about kind of real stuff where you can, how to run the tools on the cluster, and then I will not talk much about that. I think it's a lot of those things will be covered in the workshop too, but then I want to give you the idea how you would run the tools which are computationally intensive on the cluster, and the idea is that since they are computationally intensive, the cluster cannot allow everybody to run that simultaneously. So there is a queue where basically you place your job in the queue, and as soon as the cluster feels like it's ready to execute job, it will, meaning that it will have enough resources to do that. Okay, so another thing is like a lot of bioinformatics tools, they are available to you, but they are, you just need to run, you need to run the command to make them, I mean, they installed on the cluster, but kind of not available to you. So you need to run the command to make them available. So this is how we'll do it. We'll say module load and the name of the tool you want to use. For example, bowtie, BWA, SAM tools, or top hat. And then it will load the latest version of the cluster. Okay, so if you try to run the top hat, which is the splice sync alignment tool, you will not be able to do so just because it's not yet available to you. So you need to do module load and the name of the tool, and then as you run the top hat, now you will see that it works. Basically, it tells you the help message. Okay, so let's try it. So we say top hat should say something like command not found. So then we do module load top hat, and then we'll kind of load, we'll make it available. Okay, so now if you run top hat, that should work, meaning that you're getting this long help message how to run that particular tool. Okay, so again, I'm not going into much details here, just because it will be covered in the workshop too. So I think in the workshop too, you will see the way how you can place exactly this line into your bash profile. So this way you don't need to run this command to make that tool available, but it will be all the time available to you. So those things will be covered in the workshop too. Okay. Another thing I want to talk about is the queue sub. And the queue sub, this is exactly the queue we were talking about, right? So given reads from RNA-seq or any other whole genome reads and so on, you want to, for example, to map those onto the genome, you can't just run that job just because it's too heavy. You need to place it in the queue. And here, I guess my general advice is remember that there is many people in the Hoffman. Everybody wants to run the job as fast as possible. So the queue decides whom to give a priority based on two things. The first thing is how much memory do you ask and how much time do you ask. So right here, you say how much of the memory you want, like usually between 4 gigabytes and 32 gigabytes. This range, usually that's and then maximum 24 hours. Okay, so as less you're asking, as more priority you will have. So basically the Hoffman trying to get first those jobs which don't require much, and then the reason is just because it's hard to allocate resources with large job. So it will take a while until it will find those nodes available to you and so on. And then there is kind of two strategies. Either you have time, either you are willing to wait, so you run and then you wait for a while, or if sometimes you might want to try to run with the less, or like with the some memory, see if it finishes successfully, and right, otherwise it crashes because of not enough memory provided, and you increase the amount of memory. So this is kind of the strategy. You have try to read documentation for the tool you're using, which will tell you an idea, or like read, I guess, there is sort of forums discussing how much of the memory you need to provide for certain tools and stuff. But I guess in workshop 2 you will have some examples for the common tools, so you will be fine. But I want you to show, and then there is different ways how you can use the QSUB. So if you go on the Kaufman to Wikipedia, there is many ways how you can do it. This is one of the ways. This is I personally use this QSUB. This particular QSUB command, and then I will just share with you. Okay, so let's look at the QSUB command, which is which will be used to run the particular job on the cluster. So there is many options and so on, which I don't think you should care much about. I highlighted you in bold the ones you will be changing every time. And those are the name of the process, which is really important. So basically, then you submit the job, then you will be able to track it in the queue. So it's really important to give a name that you will know which job is running, which finished, and so on. And then you need to provide them two things that I mentioned: amount of memory you want to ask and number of hours you want your job to be run. And then the command itself, it will go to this script. The command itself, like for example, mapping the reads onto the genome. That command will go to this run datash. Okay, so let's see an example. This is the command we'll submit. So don't try to copy paste it. You should kind of type it because sometimes it behaves very weirdly. I guess there is some hidden characters, and then even though you copy paste, you try to run it, it will look exactly the same, but it will not work. And then you check, and then exactly the same, but I guess some hidden characters, some formatting issue. So don't copy paste it, but just type it. Okay, so this is what the things are in bold. So name, we'll just say test. 1 GB. So we are requiring 1 GB of memory because it's a very, you will see the job we are trying to run doesn't require much. Then we'll ask to run it for 1 hour, and then we'll have run sh, which is the script where we will put the command itself. I'm sorry, the command we want to run itself. Okay, so let's see what is the command we are running. So I'm not giving you any mapping. Again, we will be covering workshop 2, just a very two example. The whole thing will be just printing the sentence. Of course, it's not a real job which needs to be run through QSUB, but that's again for demonstration purposes. And then I put the sleep here, because this job is too fast. You will be not able to track it in the queue. I want it to sleep for a while, so you will be able to see it, how it stays there in the queue. Right, so all it does, print the sentence and go for a sleep for a long time. That's seconds, I guess. Okay, so what we need to do, we need to create the runsh file, put those 2 lines there, save the file, and run exactly this line. So after you run the line, this is how you can track your job. So you say qstat, which will display all the job on the cluster which are currently running. You don't care about all jobs, you care about yours. So grep by your username, right? Just do grep and username. This way you will extract only the job which you are running. Okay, so let's do it. So any questions so far?
What is the echo command mean again?
Sorry?
The echo command?
Yeah, just prints.
Prints, okay.
Yeah.
You don't specify the number of cores they are going to use.
All right. I mean, there is a way. I can, if you like, send me email. I can give you. I usually don't. That's my. I mean, unless you need to. I mean, it really gives you much lower priority. So unless you have a very heavy computational job, you should go for it. And then there is always be careful. Then if you run the job, I mean the tool, you're running mapping, and then in this run sh, as you run the mapping and you say 8 jobs. So if you do so, you need to say here 8 jobs. Otherwise, you might be fine, but you might get caught. So they will complain about that. That really your job is asking here, but you're not formally specifying it. Yeah, so I can just, I think it's on the server somewhere, but if you want, I can send you the command. I don't remember by heart how. Yeah. Because usually I don't use it. I try to avoid it because really the job stays sometimes very long in the queue. If I ask 8 cores, it's sometimes very long. Unless you cannot avoid it, if you need it, yeah.
When you say a very long time, you mean
Like a day or two. No, sometimes if you're really doing heavy computations, sometimes it depends. Right now everybody from the holidays and stuff, so I guess everybody enthusiastic to work, so people submit a lot of jobs. And yeah, sometimes it's bad in the sense that you wait a long time. And then you're doing hundreds of jobs or something like that, then yeah, your priority goes down.
Because if you share between different cores, you take less time, right?
You're right, but then you should allocate those. So
Yeah.
you should have them simultaneously available to you, which takes a long time rather than single core give to you. That's like available, give it to you. But then you, like in the restaurant, if you have 5 people right, waiting in the line, and that will take a while. And then 2 people will go in front of you, another 2 people will go in front, something like that. This will be exactly different. But if you will run it, you will get the feeling you run with the core, cores, without, you will see how it works. I guess it's like, and the thing is like never, think about your resource, think about your time, never think about the cluster time. So my strategy is like submit 10 jobs with different parameters, see who is the fastest. You don't care about the computational, the cluster resources. Like if you're really in the rush, you can submit the job asking for the course, not asking for the course this time, and see who is faster. For example, the job which asking the less resources will be faster, but it might fail just because not enough resources. Fine, another job will be run, something like that. So you're fine trying. You have 250 jobs you can run at once. So you don't be shy to submit many jobs. I think that's my advice. Right. Yeah, because you might expect it might fail for many reasons. From your side, you do a typo in the command itself. It's very kind of disappointing, discouraging. I don't know, you submit the job, you waited like 2 days, and then it's like because of the typos, it failed. Something like that. So yeah, it will be failing. Or failing for other reasons. File was not available, the system, like, I don't know, not enough memory, this and that. So there is many issues. So be kind of ready for that. Resubmitting, submitting many times and stuff. Okay, so let's try to run our 2 example. So we do vi, we call it run sh. Okay, let me check first not to have this run sh because I will clean my files. Yeah, we don't have it. Good. So let's do it run sh, and then we put exactly that line echo, just print something. My first QSub. And then the second line will be sleeping. Let's put it on sleep for a while. Doesn't really matter how much time. Put as much. Let it sleep. Okay, so yeah, you cannot see here, but then the file is here. You can just follow these instructions. Okay, so save the file, escape, shift, semicolon, WQ. So you got your file. Actually, you don't need to provide the permission for yourself. Somehow it runs without that. If you want, you can, but then you will be fine. Okay, let's run. Let's type this long command. So qsub cwd minus v minus n test l, and then the spaces are really important. I think I have a point. Yeah, so this is l. So this is l. Before h data should be l. Let me put it here. So right here. Minus L. This is not -1, but minus L. And all the spaces are super important. So here you do have the spaces. You don't have spaces here, you don't have any spaces here, just comma, space here. So try to follow it. Otherwise you will get there. I think if you save later in the txt file, the copy paste will work. This is just the problem of copy pasting from Microsoft into text, kind of. That's, I guess if you save it to text file, you will be fine. So we ask for 1 GB of data, time 1 hour. One hour and the name. Okay. Sleep, this is the example we do. This is toy example, right? It kind of has nothing to do with real bioinformatics. So all it does, it prints the sentence on the screen. But it will be too fast. You will not have a chance to see your job in the queue. I really want you to. So I put it in the sleep. While the script is sleeping, you will be able to look in the queue how it stays there. Okay, so looks good to me. Let's try to run it. So if you typed everything correctly, this is how you should. And then I will make sure that everybody can get it. But this is what you should see: that your job, that's the name, has been submitted. Okay. So now, how do you check the status? So you do qstat and then grab your username. So you will see only the job which you run. Okay.
This is the username that they gave you, not the one you gave us, right?
Right, the one which they give you. Okay, so this is how it looks like. Meaning, so WQ means that the job is staying in the queue. Okay, so it's in the queue. So you can check again, and then it's still staying. It's the same for you. If you see R right here, that means it's running. Can you see it running? Or Q? Or still Q? Okay. Yep. Okay, so the same for me. You can see that it started running. So not so bad, because we didn't ask how much. Okay, so it's running. What does it mean? So all it will do, it will print a sentence. And the sentence, and then whatever program prints, will go to the log file. So the log file will have a name the same as the name of the job. So it will be test. Okay. How to check it? Let's do ls and see the files which starts with the file which starts with test. Okay, do ls. Let's see. Okay, those guys. So the one you care about, two of them. The one which have O here, which this is the normal log. Whatever the normally program prints, it will be there. And this, in this log file, there is E here. Here, the program will write the error messages. So one way to kind of give a quick look, you do ls-l, maybe test, right? Because the directory with many files, I don't want to see them. All I want to see long list for the files which starts with test. Okay? So those are files. So even from here, you can see everything was fine. Why? Because the error log is empty, which is good news. No error messages, right? It's empty. And then something here, and then we know what is there. Whatever we printed, you can look. So do less. My first qsub. Okay, so this is how you run the job. Okay, so let me make sure that everybody can get it, and I guess there is a couple of slides left. We'll be done for today. but you check the log files, right?
Because I like went back to, because I was doing it in that
Yeah, but that's all right.
directory, and so I went back out and I was like, it's not clear.
Yeah, just check the log files and stuff.
Okay. I got a question though. So if I go to the queue stat, how would I know? Would it say if it's completed? It's like right now it's
No,
obviously
it should be
sleeping.
run. I hear, but usually don't sleep.
Right, but if you didn't finish the job, would it
Yeah.
say completed on there?
No, it will be not there.
Oh yeah, right. We'll get this.
Alright.
Okay.
And usually if you run bioinformatics, they have a log, which is
Okay.
the job, whatever, the tool finished the analysis.
Okay.
You can do it. So you go to the log file, you see the other file empty. You go to the normal log file, go to the end of the file, and see some message.
Okay. Gotcha.
Yeah. Ah, yes, okay. Right, right. Yeah, I can send it to you. If I don't, just remind me. Yeah. How would you put that in one? Ah, sure. Yeah, sometimes it does. But yeah, but here so it explains to you what can so this is just the name of the job. And then to create a log file on the or you can just to create a file and this is to create a log file on the time. I think you would. Yeah, this is kind of the thing. I mean, those we don't really need, but then we need O and E, and O stands for the local, and E stands for the error. Yeah, and then yeah, we usually do ls myself just to see that log error log file is empty, which is a good news. There is no error message. Yeah, cool. Okay, so a couple more things. So we typed many commands. So if there is a way to access them, right, you just use the up and down keys, and then you kind of see. But what about you want to see the commands from yesterday? You should quite many times press the up key, right? So there is a nice command, which is history, which tells you all the commands you ever run. Not really all of them, actually, just because it stores 1,000 last commands you typed. So given the history, you can search, like you were doing some stuff for a couple of days, and then you want exactly to do the same thing to run exactly the same command with the O, which you did 2 days ago. So you run the command history, which will tell you all the jobs, all the commands, and you search through that. And then you search for the lines or the commands which contain the word oak, for example. This way you will extract all the oak command that you type in some period which is like 1,000 of lines. So what I will try it in a second, but what I strongly suggest you to do will be run the history and save it to a file. So this way you will have all your commands which you typed during 3 days handy available, and you can search for that file. If you want to extract certain things, use the grep and search for that. Okay, so let's try it. So if we do history, so you can count how many commands did you type today. So for me, it's 1,000 because I did it previously. So it's not really me. What is the number? Do you see? Like around 400, 500? No, it's impossible. How? Yeah, because you did previously, I guess. Right, that's the maximum. So anybody who was using only recently the UNIX? Okay, that's about right. So 350. That's the number of commands you did in 3 days. Okay, sounds impressive. Okay, so if you want to save it, so I highly recommend to do it. Just save it to a file. Say, for example, history w1 workshop1.txt. Okay. So do you want to see all the grep commands we did? Grep, and then you should say oak. Yes, but then you can copy it to your laptop, for example. What do you mean? To your what, test directory? Or which one? Yeah, just do cd, go to your home and go to test. I think that's the fastest. But you're far away somewhere. Just do cd, go to your home directory. And then from home, it's easy to go to test. Just do cd test. Okay, so if you want to search through that file and extract all the commands you did with the oak, you can do it. That will be the commands. So it looks familiar, right? I guess. So this is what we were typing. And then there is also the line number, I guess, which is just tells you the line number, something like this. I'm sorry?
When I did the graph,
Uh-huh.
I got nothing.
What is it?
When I did the graph command, I got nothing.
But share your history. But you said you get 0.
Yeah, no, because I did somehow, I forgot to
Sure.
this.
Okay. So, I mean, you can look, make sure that your file is not like the less. This history. History underscore. Okay, good. Okay, so that's good. Yeah. So, yeah, just control the procedure and plus. Were you connected? Make sure you were connected. Did you do it at a local?
Yeah. Well,
Are you local?
no, I'm at,
You were all the time, right?
yeah, I'm
Yeah, I
at,
can send you that. I don't know. I mean, it doesn't make sense. It shouldn't be that. I mean, the only reason I see you were locally, and then I don't know. Okay, so that's okay. So couple of things left. I guess I was telling you a lot about using the Google to kind of finding the answers. And I want you to show the extreme example. So I want you to show that even though that might be impossible, I mean, the command is too long, it's like too complicated, but it will work. So this is the extreme. I'm sure you will be dealing with much simpler example. So think about you want to convert the columns to rows in oak. I mean, no, let me say this. You want to convert the columns to rows, and then if you have this task, you might think that if you have the columns, then probably the oak might be a good choice. So you try to write the query for Google like this. You say convert columns to rows, and then you specify, because it will tell you like
many things. You don't specify the oak. You should say particular tool you want to use. And okay, so you say oak. And if you do so this is what it will typically look like. We can do it together. But usually you look for something which is solved, so people are so nice, they even tell you that the problem was solved or not. Okay, so you look for something which is, yeah, we'll have this. Okay, let's try it. Let's open the Google and write exactly this. Convert column to rows and oak. Okay, convert columns to rows. Okay, so I did use it before, so this is the first choice for me. Might be somewhere lower and something like this, but that's you want to click. Convert the columns to lines using oak. Okay. Okay, you scroll down. Usually you see person, somebody explaining the problem, saying I cannot do it, I got stuck, nothing works, life is miserable, help, stuff like this. Okay, and then you can even, I mean, he's so nice, he explains the problem. This is what he has, the metrics, and then he wants to convert it this way, right? Okay, so this is exactly what we want. And then you scroll down, you look, somebody saying, answering him. You don't need to read so carefully. Somebody says it works. Okay, you scroll down. So this looks fine to me. Okay, so that's your oak command. Okay, it looks long, but it's all right. Shouldn't be worried. I mean, let's look at the structure. So the structure is the same. It's oak, single quotes, curly braces, in file, which you can guess what is that. This is the input file, and you're doing redirection, and then output file. Okay, do you care what is inside? You shouldn't much, right? Okay, let's try it. The only thing which you should be very careful, then you're copy-pasting things. So you can see you should have a single line, as you don't have it here. So before inserting into your UNIX, I would rather insert in the text and make it a single line, and then insert it. Okay, you want to try? So first let's create that file. I just want to create and show to you that it works. You can create a random file if you want, actually. It doesn't matter. So let's do vi, I don't know, oak.txt. And then copy paste that file. Or create by yourself. It really doesn't matter. Okay, so let's save it. So now let's take the command, let's copy paste it. All this long command. Open any, how do you call it, text editor. Any you use, it doesn't matter which one. And then what you want to do, be careful with the space. I guess, yes, we don't add extra space. Here, and should be a space. But make one line. It's fine, because here, and this. Okay. So I would not copy this part, because we will put the file name, right? Okay, so I would copy only this part. Here, pretty long. Control C. Okay, ready. Control V. It's quite long. Okay, so what was the file? Oak. Okay, so that's your command. Super long, super complicated. You don't care. Should work. Okay, that's the magic of Google. It's a magic of common knowledge, sharing the knowledge, right? Okay, so is it something that you expect? I guess, right? Converting columns to rows. So again, I don't think you will be dealing with that every day, but I'm just saying that those, and then if you want to save it to the file, right? I didn't finish. Oak transpose .txt, and then you save it new version of the file to a new file. So again, I'm not expecting you to deal with that on every day. Instead, I just want to encourage you to use the Google, and then there is solution there, and then sometimes you don't necessarily need to understand all the details, but then rather understand the structure and the problem overall. Okay, so again, that was kind of motivation for you. So you remember I was asking you the question, right? Do you need to become a programmer? So I don't think so. So I think we got covered enough knowledge and skills, which I hope you will be using. And then the Google is handy. There is a lot of forums. People are nice. They discuss a lot. They explain. So you can use that. So you kind of have the entry ticket for this to enter those forums and kind of understand. Okay, so I have an announcement that we are running the pilot stage for the bioinformatics core under the QCB, and then we offer the next generation sequencing analysis where we can analyze the data for you free of charge, requiring the fellow which analyze the data to be included as a co-author in eventual publications. So currently we run the pilot stage for the RNA-seq analysis where we can map the reads, we can identify the gene expression, and then we can find the genes which are differentially expressed. So if you're interested, contact me or Matteo or both of us, and then we'll provide you the guidance. Okay, so also a small announcement, the project we are running under QCB, where we look for the reads which never make it to the genome, and we look for the repeat elements among those, for the VDJ recombination, kind of to quantify the immune system, for the circular RNAs, for the microbial community, so on. So if you have some RNA-seq data, you want to explore the things which were not explored just because you usually throw them away. So we are planning to put the pipeline again. It will be available so you can run it. So let me know if you're interested. Okay, so I forgot to print the survey. So I'm relying on you. I will send you the link. So please, because this is what I observe. If I do the survey in the class, paper-based, usually I get like 100% feedback. If I do online, I do get like 70, 60. So let's try to increase that number. Okay, thank you. Yeah, and then if I forget to send, I will try to send the slides very soon, and then the video, which I'm doing for the first time, I will upload to YouTube. So if I don't do it like next week, just feel free to remind me. And then